This is part 5 of the bicycle fork video. In the previous video, we made it all the way to step 6, which included inserting the master file, making a tilted right plane, a tilted plane for the crown, the front layout of the fork, a sketch for the top circle of the crown, and step 6 was a layout on the right tilted plane of the fork blade. This video will take us through steps 7 through 14. Step 7 will be to make the profile planes for the boundary that will form the blade. Step 8 will be to make a projected curve for the trailing edge of the blade. Step 9, a projected curve for the leading edge. Step 10, a projected curve for the outside edge. And step 11, a projected curve for the inside edge. Step 12 will be to draw the boundary profiles. Finally, step 13 will be to combine all these into a boundary that forms the blade. The final step of this video will be to taper down the blade to prepare it for the addition of the front dropout plate. Now let's roll the feature tree back to step 6. Make our front layout sketch visible and start adding the profile planes. In the front layout sketch, I drew some lines that will indicate where the profile planes will go. I try to make one close to where the bend is going to be in the blade, one about halfway down, and the last one will be right where the blade ends and transitions into the dropout plate. To do this, I'll go to my reference geometry planes. I want to make a plane perpendicular to my front plane and passing through this line. That will be my first profile plane. Repeating that, again go perpendicular to the front plane, passing through this line. By the way, it defaults to perpendicular. Finally, one last one. Which gives us our plane down at the bottom of the blade. I've renamed these profile plane 1, 2, and 3. Profile 0 will be on our front plane. The next thing to do is start making our projected guide curves, which will be step 8. So making my right tilted layout visible. The first one I'm going to start with is a trailing edge. To make that, I need to make a copy of this curve in the front view and this center curve in the tilted right view. Starting with the front plane, making a new sketch, all I have to do is copy this curve, finish the sketch, and now on my tilted right plane, make a new sketch, copy this curve, and finish the sketch. Going into Insert, Curve, Projected. Just select the two sketches using the Sketch on Sketch option that I just made, so sketch 46 and 45. And that gives me my first projected curve, which forms the trailing edge of the blade. The next step is the leading edge. That requires copying this curve from the front view, and we are going to reuse this curve from the tilted right view. Making a new sketch on the front plane, copy just this curve using Convert Entities, finish the sketch, and on the tilted right plane, a new sketch, once again copying this middle curve, finish the sketch. Just like before, we make a projected curve from these two sketches here. So Insert, Curve, Projected. And here we can see amid the clutter our leading edge of our blade. Now we want to make the projected curves for the outer and inside guides for the blade. This time we are going to be using this curve twice, and this curve includes this curving portion here and the straight portion that goes from the bottom of this diamond up to the top of the diamond. We need to copy both elements. So on my front plane, sketch, using convert entities, I'll grab this portion here, and finish the sketch. On my tilted right plane, making a new sketch, again convert entities and grabbing these two elements of the outside guide and finish the sketch. Now I can just project these together, insert curve projected, grabbing the last two sketches that I made. That gives me my outside guide curve, which you can see here. I've hid the sketches momentarily there to make that a little bit more visible. And the final curve will be the inside guide. Once again, making a sketch on the front plane. I'm going to copy this curve a second time using convert entities. Finish the sketch. And now my tilted right plane, making a new sketch and copying these two elements here. Finishing the sketch and doing an insert curve projected, selecting the last two sketches that I made. And that should give me all four of my projected curves. You'll notice from the front view, the outside and inside curves look like they are in alignment with each other. And from the tilted right view, the leading and trailing edge curves look like they are in alignment with each other. Step 12 is going to be to make all the profiles for the blade. And since we've made our guide curves first, and the profiles have to be pierced to those curves, we don't have to show any of our other sketches in order to create these. For this example, I'm going to make an oval-shaped profile. We can make an oval shape here because we know that this is a symmetrical diamond, but when we get to the other profiles, we can't guarantee that these blade guides will pass through the profile planes in forming a perfect symmetrical diamond. So the best way to do this is to make something that looks like an oval, but actually use the spline tool instead. So making a new sketch on my front plane for what I am calling profile 0, I'll select the spline and just draw 4 spline points and close the spline. Now I want to be careful not to play around with these handles at all. Now I can pierce each of these points to the guide curves. So holding my control key, I'll just pierce each one in turn. And the final one. This turns the entire oval-shaped spline black. And if I click on this, I see that all of the handles are going either vertical or horizontal without my having to touch them. As soon as I start fiddling with this, this is going to look non-oval shaped. So do not do anything to adjust these handles. That's my first profile. My next profile will go on this profile plane. Again, making a new sketch, and again using my spline instead of the oval tool. Making a closed oval, and again piercing the corners. Now you'll notice that these projected curves sometimes have multiple pieces to them. So when you're making your piers, select the portion of the curve that's actually passing through the profile plane. Otherwise you'll get an error when trying to make your piers. Finishing this sketch, I can now move down to this profile plane, make a new sketch, again using the spline. You'll notice how these ovals are getting skinnier and skinnier as we go further down the guide curves. Finishing that one, we'll get to our last profile plane, new sketch. So our final profile. And finally, now we see we have 4 guide curves, 4 profiles. You might find, depending on the shape of your fork, that you even need to add a profile plane tilting halfway through the bend in the blade. In order to do that, you'll have to make a sketch element in your tilted right plane and make a plane going perpendicular to the tilted right plane and passing through that sketch element. If you're fortunate, you won't have to add that extra profile. Now we're all ready to make our boundary. One thing we notice is that the very last profile is not going all the way to the end of the guide curves. One nice thing about the boundary tool is that the guide curves can actually go further than the last profile. This is something that lofts usually don't like to do. So we've done most of the hard work. Now the easy step is making the actual boundary. So going to our features, boundary, I'm just going to select each profile in order. And I'll try to select them all near a common corner so that they don't twist. And now I'll select all the guide curves for direction 2. Let me turn off my curvature cones. And it's a good idea to make this profile normal to profile so that when you mirror this blade to the other side, you get a smooth transition going through the mirror plane. Now we'll notice at the bottom that even though our last profile is ending here, the boundary will actually go all the way the length of the guide curves. We actually do want our blade to end on the last profile. So what we are going to do is choose this option, Trim by Direction 1. Since Direction 1 is our profiles, what it means is it's going to trim the boundary to the very last profile, which is going in Direction 1. So just by checking on that, it trims the boundary back to this profile here and ignores this portion of the guide curves. And here is our completed blade, step 13. The final step 14 for this video is going to be to trim down the ends before the attachment of the dropout plates. To do that, let me make my right tilted layout visible. We're going to use these sketch elements to trim away this excess material. So on my right tilted plane, a new sketch, I'm going to copy these lines into my sketch using convert entities. So this line here, 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 and here. Then I need to do a cut that's going to cut through here and cut through here. So I need to just complete these areas here. by drawing some extra lines that go outboard of the blade. This dimension doesn't really matter, although it's not a bad idea to add an actual dimension to it. So we just make that 10, for example, to guarantee that this is always going to be going outside of the blade under all circumstances. Now all I have to do is a cut going this direction that will take away that material. Through all. And there's my taper cut, step 14. This concludes part 5, and part 6 will finish up all the rest of the details to complete the fork.